Hey Melody, welcome back. Good to have you. So let's pick up with this textbook, Chapter 2. But before we get to that, I want to show you some pages that I wrote that were inspired by our conversation last time. So here I've got our page on William Harvey.
William Harvey. In the year of 1628, a man by the name of William Harvey is accredited with the discovery that the human heart is a pump. Because of this book, De Motu Cordis, an anatomical account of the circulation of heart and blood. Before then, it is claimed that many doctors believed in the teachings of a Greek doctor, Claudius Galenus, also known as Galen, who taught blood was made in the liver and didn't circulate through the body. In all, William Harvey is accredited to leading a scientific revolution that significantly changed people's understanding of human anatomy.
Good job. The whole first paragraph, I was really concerned about it being too much of a mouthful, but I think you handled it really well.
Okay. This story comes with a lesson. Just because an idea is popular, that doesn't automatically mean it's right. If William Harvey never thought to question what he was taught, people today would still believe the teachings of Galenus and not know that the heart is a pump. Even if the leading experts of our today believe one thing, it is okay to question it. A fallacy is a fancy word for describing a bad argument. The bandwagon fallacy, also known as an ad populum fallacy, is to argue that something is true because many or most people believe it. The earth must be a globe because most people believe it. Just remember, people can't vote on whether the heart is a pump or not. Truth doesn't care how many people believe in it, and sometimes popular beliefs are wrong.
So then I got the sheep there at the bottom.
I think those are pigs.
Or pigs.
I don't know. I think they're pigs.
I don't know where we're going, but from the look of this crowd, it's gotta be good.
Then they're jumping off the cliffs.
So I wouldn't have this page if it wasn't for you. Next page.
Okay. Also, just because many people before Harvey were wrong, that doesn't mean that their views were not scientific. Think of two portrait paintings, one by a little girl and the other by her mom. Both paintings still qualify as scientific models. One just happens to be more accurate than the other.
What do you think of that?
I feel like that actually does explain it very well. Because, it's still right and it's still science, but it's not fully right.
It's something that we're continually developing. Mm-hmm. We're trying to learn how to describe things better. So the more puzzle pieces we put together, the better it is.
Yeah.
Okay. So I still have two other pages that I want to add to that. One is going to be about the whole Challenger explosion that we talked about last time, about how the Challenger astronauts are still alive. And yeah, so I haven't written that page yet, but I'm going to. And so we'll talk about that next time, as well as I'm going to write a page along with that one about Project MK Ultra, the government mind control operation that they've actually admitted to. It's really crazy. So,
wait, they actually admitted it?
Yeah, it's totally declassified. I won't say totally,
how
but
long
it has been
ago
declassified.
did they do that?
I'm not really sure. Yeah. So yeah, we'll talk about that more.
They don't do it anymore, do they?
I've got Cindy over there from our meetups. She's pretty convinced that even though they say they're not doing it anymore, they're still doing it. And yeah, so she's got a bunch of evidence for that. It gets into a huge, major human trafficking rings that are still going on today, and yeah, right there at government military bases and stuff. It's just really messed up. Kind of dark. Don't really like to get into all that stuff, but I think it's worth writing about. But yeah, let's go on to chapter 2 here. So chapter 2. Earth Science in Action!
A lesson from the past. The legend of Eratosthenes. Eratosthenes. A story is passed on from generation to generation about a man from ancient Greece named Eratosthenes who assumed the earth was a globe and set out to measure its circumference by measuring the lengths of shadows in different locations. Some say he looked at shadows at the bottom of 2 wells, and others say he looked at the shadow cast by 2 sticks. Not all of the stories are told the same way, but that is how it goes with folklore.
So I've got 2 videos here. I've got the little QR codes for each one, and I've got Carl Sagan here saying it's 2 sticks, and Neil deGrasse Tyson saying it's 2 wells that he was looking at. So consider this.
Okay. Remember how earth science is a...
But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world. In a way, made the world. Because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out, sticks do. Eratosthenes asked himself how it could be that at the same moment, a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here's a map of ancient Egypt. I've inserted 2 sticks, or obelisks, one up here in Alexandria, and one down here in Syene. Now, if at a certain moment, each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths.
So his entire claim depends on the light from the sun being parallel. And when the light from the sun is not parallel, his claim falls apart. That was Carl Sagan. Now let's hear from Neil Tyson.
So now if the Earth is round, how big is Earth? You might want to check for that. There was a famous experiment conducted by Eratosthenes. Eratosthenes. And there are 2 cities in the old world, and one of them, they knew that at 12 noon on a particular day of the year, that the sun was directly overhead and you could see the bottom of a well.
Oh, okay.
You don't run around looking at the bottoms of wells.
No.
Because the light doesn't take, it's just, no.
Doesn't get down there.
Doesn't get down there.
How can we use this observation to see if Earth's surface is curved? We needed another well. Turns out we can't see the bottom of both wells at the same time. What might explain this?
The whole emphasis on wells instead of sticks is the main thing I want you to see here. But if you hang on, there's a little bit more I want to show you.
Well, there are 2 possible explanations. First, we could have a flat Earth with the sun that's small and close by, so that the light hits the second well at an angle. Or second, we could have a curved Earth with a sun that's big and far away, so that all the light comes in parallel, but only one well at a time is lit all the way to the bottom. Turns out with just 2 wells, there's enough wiggle room for both explanations to fit our observations.
I'm really happy that he acknowledges that, which is something Carl Sagan never did.
Eratosthenes only had 2 wells, but what if he had added a third? With a third well, it doesn't matter where the sun is. No flat Earth model can explain the angles of all 3 shadows.
And that's where Neil Tyson fails us. Non-parallel sunlight explains it just fine. So the key thing here is whether or not the light is parallel. That's what everything hangs upon, right? So when the light from the sun is not parallel, everything falls apart here for them, right? Because that's the key thing. Everything hangs on that. He showed the parallel lines being the difference between between the flat Earth model and the globe Earth model. That was the difference. One had the non-parallel light, and the other one had the parallel light.
I have a question. It
Okay.
doesn't exactly make sense to me. If, like, astronauts and, like, all of those scientist people believe that it's, like, the light is parallel from the sun, does that mean, like, if this is the sun and here's the Earth, then, like, the sun would go down to the Earth. Do they believe that it goes, like, up to outer space at the same time?
They do. I think they're just talking about the light from the sun. Only the light from the sun that reaches the Earth is parallel. But they do acknowledge that the light from the sun that's not reaching the Earth is not parallel. Yeah.
So they think it's like, I don't know, like see a picture of how they draw it out, because it would be like straight down, like everywhere
I like that you're
else.
thinking about this, because I heard this in, like, if the light from the sun was parallel, we should maybe get light on the Earth maybe one day, and then the rest of the year would be in darkness, because unless it's like turning or something like that, you know what I mean?
Yeah.
Yeah. Then the light couldn't hit any other angles. So, yeah.
It's really confusing.
Only light in front of the sun is parallel, but at a 90-degree angle from Earth, all that stuff should be in darkness. Yeah. If it's perfectly parallel. But, yeah,
It's
that's
just
not
like-
quite their claim, but, yeah, you get it. I like that you're thinking about this.
It's just like weirder and weirder to like listen to like more of what they believe, because I just feel like, okay,
It falls apart so quickly.
it's like that's not true. So why do we have to keep on learning about it?
Yeah.
You know,
So-
like at school and stuff. It's like,
Yeah. Well, again, it's going back to William Harvey. They're just repeating what they're told. And not enough people are questioning. When enough people start to question it, that's when we have a scientific revolution and people just suddenly say, you know what, that's wrong. We're just going to stop teaching that entirely. And that's
Yeah, that'd
kind of
be
why
awesome.
I'm writing this textbook.
and then maybe we'd be smarter.
Yeah.
But I'm pretty sure like the government is like, I feel like maybe they know a lot more than we know,
Mm-hmm.
and they're trying to keep all of the smartness with them,
Uh-huh.
and then keep us dumb, and then do whatever creepy craziness.
Yeah, I'm not the
behind the
criminal
scenes.
mastermind here, so I have no idea, but that's a good speculation. Yeah, I feel like that's the case in so many instances when it comes to, when it comes to making money. If you know a great idea, you don't want to share that recipe, the secret recipe, with everyone else, and so you kind of have a false recipe and that's not as good, and you share that with everyone else, but keep the good recipe for yourself.
Yeah,
So,
almost like if your mom tells you to go make oatmeal, and you're like, I don't want to make oatmeal. You make it better. Come on.
yeah. Except for, I think, with your mom,
I don't
it's
like
not for that.
oatmeal.
What? Okay, well, I think she would want you to learn the good stuff, and that we should have to make it for you. So, okay. Consider this.
Okay. Remember how Earth science is a broad study of astronomy, geology, meteorology, and oceanography. While oceanography didn't play a role in the Eratosthenes project, take notice of the presence of the other three. What other three?
Okay. Earth science is a broad study of astronomy, geology, meteorology, and oceanography.
That's four.
Okay. And he's taking one of those into account and kind of ignoring the other three. So let's kind of try to add on to this by putting those puzzle pieces together. Take a look at what the bigger picture is by putting the puzzle pieces in there that he's not seeing.
Okay.
Okay, so let's go on to the next page.
That is a lot of QR codes. Okay.
Yeah, it's really important to actually hear them say it. So we've got the videos of them actually saying it, and yeah.
Okay. According to the World History Encyclopedia and the Penn Museum, this is what the world looked like according to the Eratosthenes. With that being so, it should be more than apparent that Eratosthenes was more than just a little bit wrong. Nonetheless, many leading science figures in the world, like Dr. Michelle Thaler and Dr. Neil deGrasse Tyson, claim Eratosthenes proved the Earth was a globe.
What do you think about that map of the world?
Where's America?
It's not in there at all. All you see is Asia, Europe, and Libya, which is like...
What is Libya?
That's part of Africa. That's like the top right-hand corner of Africa.
It's like they forgot about everywhere else.
Yeah.
Wait a second. Where's Alaska?
Alaska's not in there. Alaska's part of America.
Wait, what is he... How's that even supposed to fold into a globe, though?
It doesn't. Yeah.
How does that prove anything? How is he like the founder of Globe if it looks like that? How do they expect the globe to be real if he can't even get it right this much?
Yeah. The funny thing is that this is mainstream sources that are coming out and saying this. This is the map of the world according to Eratosthenes.
But why do we believe that?
It's just amazing. It's funny when big names out there say this kind of stuff, and yet they give him so much credit and say, "Oh, he totally proved that the Earth is a globe." This is wild.
It's like trying to give extra credit to like a little 2-year-old because he only knows so little, but like it's not fair to like everyone else that it actually is right.
Yeah. So I've got this quote from Michelle Thaler, and you can just read that.
Okay. Concerning the Eratosthenes project, a really simple proof that the Earth is a globe is that on any given date, at different cities and different places around the world, the sun is at different angles in the sky. That wouldn't happen if the Earth wasn't round.
Do you have any thoughts on that?
Still doesn't prove that he's right, though.
You say that
It's like,
we've got different shadows at different angles at different places on Earth. So
wait.
here, this might help. This might help.
And all that Eratosthenes did was he measured the difference in the angle of the sun. It was straight overhead in Syene. In Alexandria, it was a little bit less than overhead. And he rationed that change in angle from one city to another was probably indicative of us being on a curved surface. And you could make all kinds of measurements even between those two cities and see that the angles were different. The sun was at a different place in the sky. Using this, he actually measured the circumference of the Earth, and he got it right 2,000 years ago. So another really simple proof is that on any given date, at different cities and different places around the world, the sun is at different angles in the sky. That wouldn't happen if the Earth wasn't round.
Let's take a look at this next page. See, we've got different angled shadows right there across the table.
This table is a ball.
According to Dr. Thaler.
To avoid academic pitfalls when hearing scientific claims, it is important to continually ask, what is the foundation of this claim? In the instance, the Eratosthenes project was founded upon the belief that the light from the sun between Alexandria and Syene was nearly perfectly parallel. With that, please take notice of just how much a person's view concerning astronomy can affect their views of geology. The Earth's circumference to light from the sun is parallel.
Okay, so you guys seen this?
It sort of bugs me, though, because, like, people are like, oh, yeah, like, I'm, like, super smart at this, and I know everything, but I feel like these scientists these days are just memorizing everything that they've been taught in the past years and pretending that it all makes sense, but they don't have the actual science. It's just, read it from the textbook. I know that now. Okay.
Well,
somehow it makes sense.
this is exactly what we were kind of talking about just barely when it came to William Harvey. William Harvey is everyone around him. They were just passing on what they were told for generation after generation.
Yeah, but like I feel like if I was a famous scientist, I would just become mentally insane and like, what is this Earth?
You gotta start questioning things, right?
Like, what is happening? Because like, if a math teacher asks like, what is 4 plus 4? Like, it could easily just be said 8, right?
Mm-hmm.
That'd be the simple reasoning when like if someone's like, what shape is the Earth? Flat, okay? But like, then someone's like, actually, somehow, it's actually round, and then people are like, okay, and then they're like, and also like, people live on the Earth, on like Mars and like different aliens and like, and then they start making up their own story until it's not actually true, and then you're like, wait a second, dragons are real, dinosaurs are real, unicorns too. They found like real mermaids. Wow, and then you get
You're
lost.
kind of touching on dinosaurs there. Like the whole name dinosaur is actually really new.
Dinosaurs.
So before like modern times, anytime they found like old fossils and stuff, they were dragons. That's just what they were called. So
Dragons.
yeah, dinosaurs is a totally new term. So
I'd call them animals.
yeah. Okay.
Dragons. How old are dragons?
There's writings about dragons in the Bible, actually. Yeah.
I guess I thought that dinosaurs, dragons, went extinct before people came. Like, did they see like little ones that were like almost dead, but like not quite, or like what?
That's a whole other ballgame. Like exactly man's interaction with dragons or dinosaurs. I don't think they'd be writing about dragons in the Bible if
they weren't
weren't seeing them.
important.
If they weren't seeing them.
Also
Yeah.
that.
Yeah. In fact, in the Apocrypha, which is like a whole set of books that were taken out of like the King James government Bible, there's an entire book called, I think it was Daniel and the Dragon, where Daniel and the Lion's Den actually slays a dragon. It's crazy.
What?
Yeah.
Is that fake because it's like government or like?
Like it's in the Catholic Bible, that's them. But yeah, I'm not saying, I trust in the Catholics entirely, but yeah, it's still an interesting old document. And yeah, exactly the veracity behind that, I don't know. It's interesting. Yeah. But okay, so here we got our next page, and I've got 4 different links to NASA talking about this parallel sunlight. They've got another Eratosthenes video right here from NASA, and
Eratosthenes.
yeah, and don't feel bad about saying it wrong, because if you noticed, Michelle Thaler also said it wrong.
Wait, what did she say?
I don't remember. She's just said it a little differently.
There was a really brilliant Greek scientist called Eratosthenes, and Eratosthenes noticed that there was a town called Syene.
And then I heard another person say it weird, not in this video, in a different video entirely, where he said Eratosthenes. But I'm like, you know what? I kind of like that pronunciation of it. Eratosthenes. It sounds a little bit more Greek anyway than Eratosthenes, but I could go for that one, but it still sounds better than her version of
Eratosthenes.
So let's go on here with the next page.
Contradictions are like puzzle pieces that don't fit together. They are a means by which we are able to detect lies and errors. NASA claims that the light from the sun is parallel. Is that page 1 and page 2?
Yeah, link 1, link 2. So, yeah.
At the same claims.
Oh, I forgot time. I'll go ahead and make a fix to that. Thank you for
Okay.
pointing that out.
Should I keep on reading?
Yeah, go ahead and keep on reading. That's why we're doing this whole thing, so I can get that extra set of eyes to see the typos that I don't see.
Comma, yeah. Okay, but at the same time, Penumbra exists because the light from the sun is not parallel. When when their budget for the year of 2025 was $25.4 billion, that should set off a red flag saying something isn't right. Penumbra is a partial shadow that occurs when light hits an object at different angles. It demonstrates that the light from the sun is not parallel. If all the light from the sun were parallel, penumbras could not exist, and the shadow of the moon during a solar eclipse would be the exact size of the moon, like a cookie cutter like a cookie cutout.
Does that work for you in
Yeah.
the picture? Help you understand it?
But could NASA say that if the Earth was round, then it would work? Or does that still not work?
I don't know what NASA would say on this matter, but if the light from the sun was parallel, this would be the case, whether it's a globe or a flat Earth.
Okay.
Either one. Okay. And then we got to hear this next paragraph because it's a big one.
Okay. NASA claims the moon is 2,159 miles wide, yet also claims the moon's shadow is about 300 miles wide. That would make the moon's shadow smaller than the moon itself. Yet, in their diagrams, they show a shadow larger than the moon. These are some puzzle pieces that most certainly don't fit together. That's weird. So they're saying that like the shadow is smaller than the thing making the shadow?
Yeah.
Wait. No, I don't think that. Well, when you're walking on a sidewalk and you have a shadow and it's like super duper small or super duper big and tall, would it work like that?
In that case, you're looking at your shadow at an angle, and so that's going to lengthen out your shadow a lot. But this is like directly having the sun directly up above, where it would be the same.
And then it becomes super small of a shadow?
Yeah. So you have the sun and moon and Earth in a direct line, so you're not looking at it at an angle.
That's weird. Why do they say that?
Yeah. Well, right here, they're saying the exact opposite of what they're saying with the Eratosthenes experiment. So right here, you're looking at all these different angles from the sunlight, and they are saying that the light from the sun is not parallel.
That's what I was thinking.
The shadow is at a different size because the different angles that it's coming in at.
Wait. So they just barely said... So it annoys me so much that like NASA just like does that. They're like, oh yeah, cats are big. No, cats are small. No, they're big.
Yeah, it's a contradiction.
It's like, yeah.
Yeah, they're trying to say two things at the same time that are completely opposite of each other, and it's just not working together. Which one is it?
It's like your best friend coming up to you one day and saying, oh yeah, this is my mom. You know Bethany? Yeah, she's my mom. And then like a couple minutes later, oh yeah, see, yeah. Did I ever tell you that Rob is my mom or something random? And you say that like 20 times.
Mm-hmm.
And then they're just like, make up your mind. Come on.
Yeah.
Who is it?
Is she your mom or is she not your mom? And she's like, oh, is she like maybe she's like a stepmom or maybe an adoptive mom? And no, she's not my mom at all. It was like, then why are you calling her your mom? Yeah. So, next page. Here we go.
On top of that, if you subtract the size of the 300-mile diameter of the moon's shadow from the claimed 2,159-mile diameter of the moon, according to NASA, the light from the sun is 1,859 miles off from being parallel. Keep in mind, the distance between Alexandria and Syene was about 525 miles concerning the Eratosthenes project. That is something that definitely deserves some consideration. When the entire project depended on parallel lines, his entire conclusion falls apart and is revealed to be nothing more than an academic pitfall.
Is that too much of a mouthful?
I think it's pretty good.
Okay. Let's go on to in here.
Okay. Thankfully, you also don't need to wait for a solar eclipse to occur in order to see the penumbra. If you pay attention to the shadows of the tree leaves, you might notice that often the shadows are not the exact same shape as the leaves themselves. This is because of the penumbra. The non-parallel sunlight causes the edge of the shadows to get blurred out. It isn't a lot of penumbra, but the width of each leaf is really small. The moon is a lot bigger than the leaf, so the moon casts a lot more penumbra.
What do you think of that?
I think it's cool, and it makes sense because you don't get to see every single little detail of the leaf if it was like super close up to the ground.
You can see all these little ridges on the leaf
Yeah.
there, and you don't ever see that on shadows.
Yeah, if you were to see like the shadow and it was like the exact same size. Wait, does that work?
Does what work?
When a leaf is on a tree branch, it's farther away because it's up higher.
Mm-hmm.
The moon, what they claim, it's higher up, so that's why the shadow's smaller.
It's higher up into. Yeah, it's kind of
Does
a
that
weird
work?
thing. It's kind of weird. I'm glad that you brought that up because, yeah, is the leaf getting bigger or smaller, and how does that compare with the moon?
Because when you think of it, like the tree, like when you see a shadow of a leaf, like it's not the exact same size. They're a lot smaller looking.
Yeah. Wait, you think the shadows are smaller than the leaves themselves?
Yeah. If you think of it,
Uh-huh.
I don't think every single little leaf is like about this big. 'Cause those leaves are big, like as big as your hand or bigger.
Yeah.
When you look at the shadow on
I
your
guess
floor,
the angle of the ground makes a difference because sometimes I can lengthen them out. You know what I mean? Kind of like your shadows.
Maybe.
Sometimes you can get really tall shadows off of yourself. Yeah. So
Maybe.
it depends.
But I'm sort of seeing how the moon could become smaller looking.
Yeah. If
Do you agree?
it can be smaller if the sun is bigger. If the sun is bigger than the moon, I could see how it would be smaller.
But do they ever claim that the sun is smaller?
No, they claim the sun is like way bigger than the moon because it's like 93 million miles away.
So should that work?
And so I kind of view it as like this little V where you have like the moon here, and then like the farther away you get, the wider your V becomes until the point that like the sun is huge compared to the moon, and that's kind of.
So does
cool.
that still work?
Does what still work?
Where the sun shadow can still be smaller?
Yeah, it can be smaller so long as the sun is a lot bigger than.
Okay, so their example of that, with the shadow being way smaller than the moon itself. Do you think that works?
Yeah, theoretically that could work. Yeah. When it comes to being smaller, but the big thing here is whether or not it's parallel or not. And yeah, I took that picture right there, right in our driveway with the leaf and all the shadows, and it's interesting how a lot of times the shadows don't even have like the leaf shape at all. Like they just kind of get blurred out into like circles and stuff, you know. I was kind of noticing that how the shadows of the leaves tend to change shape throughout the day.
I think that helps because, like, if you were to be painting and you have to, like, exactly paint the exact person that you're, like, you'd have to make practically a copy and, like, painting every single little hair that's flowing in the wind or something.
Mm-hmm.
Yeah.
Wait, the painting has to do with.
Like, since a shadow, it gets changed because of like the non-parallel sunlight.
Mm-hmm.
like, it makes it blurry, like how it shows in the picture.
Mhm.
So, like, if you were to be painting a picture of a person, like, standing on grass, and then they've got their shadow, you wouldn't have to,
Paint every single
every single little
thing in the
hair.
shadow. Yeah, it kind of blurs out, and so you don't have to be super.
You don't have to worry about painting the shadow.
It can just be a little blurry, and it's okay in art. Yeah, that's heaven sent. Thank you for not having to get the mirror-like image like perfectly down. So it makes doing art a lot easier that way. So, yeah. The other thing I wanted to say here about shadows is sometimes you can like hold up your hand and look at the shadows, and like your shadows will get like, it'll merge your fingers together. How many fingers am I holding up? And judging by the shadow, sometimes it'll like add you extra fingers. Yeah. And
Really?
sometimes it'll take fingers away. You hold up.
I thought
yeah.
that was only, like, if you've got, like, more than one light source.
And that's kind of the thing with the non-parallel sunrays. It does really weird shadows because the light kind of bounces off of different things. But it was more so.
If it was non-parallel, and you got, like, more than one light source, you know,
Mhm.
could they, like, cross?
Yeah,
They can,
they
like,
cross.
go, like, literally any direction.
Well, that's kind of what happens a little bit.
It's like a
But,
sun could go like that.
do you remember the last solar eclipse? We went over to the park and we were looking
Yeah.
at our shadows in the last solar eclipse.
That's
And
so
that's
cool.
when we were really looking at our shadows and how many fingers am I holding up? That was one of the things we did. And part of the reason why is because some of the light is coming from one side of the moon and from the sun from over there, and then some of the other light was coming from the other side, and so it was acting like light coming from multiple sources.
Yeah.
Does that make sense?
There was this one time, and it was so weird. It was, like, in the middle of the night, you know, I had to go to the bathroom, so I went into the bathroom, and there was, like, a little nightlight, and I thought my eyes were going crazy. I was like, what is wrong with my eyes? Because, like, I would move it, like, super slowly like this, and I had, like, 20 fingers. It looked like I was, like, super fast, but, like, it was clear. Like, I could see clearly, like, 20 fingers when I was moving it, like, that slow.
You're just looking at your shadow there, and
But, like, it was so weird because
Yeah.
of, like, the light. And I was, like, freaking out. I was like, what's wrong with my eyes? Do I have, like, superpowers? I actually thought I had, like, superpowers or something. I was like, what happened overnight? Like, and I was, like, sort of freaking out. And then, like, it happened, like, when I shook my head and everything. Like, I was like, what's going on? And then I went up to Mom and I was like, Mom, I think I've got superpowers. Something's wrong with my eyes. Look, when I do this. And then it didn't work. And I was like, wait, what? And then only in the bathroom it worked. And she's like, yeah, it's because of, like, the light source or whatever. It's so cool, though.
yeah, kind of reminds me of those strobe lights, about how when you're kind of moving around with strobe lights, it can do weird things to the motion of your hand. Yeah.
What are strobe lights?
Strobe lights are lights that blink really fast. You sometimes see them like around Halloween time.
Oh,
Yeah.
where it's, like, pitch black and then you can see. And,
Yeah.
like, usually in, like, horror movies or, like, jump scares. It's
Yeah. And so it looks like they're walking funny. Like you're here, and then no, you're here, and then you're here, and
Yeah,
yeah.
it's like,
Well, I see about 3 or 4 lines.
Yes, and in fact, what I'm doing is just waving a stick in front of a television set. What you do is you turn it to where there's no station, so that you're just getting a blank screen like that. And now take the stick and
Okay.
wave it in front of it, and you can get 1, 2, 3, or 4, up to 6, depending on how fast you wave it. I see about 4 from here.
Yeah, even 5.
Now this is based on an effect called a stroboscopic effect. Do you know what that means? Strobe.
Well, I've heard strobe from dances, and they have a strobe light, and they put it up and it flashes, and it makes the people look like
People
they're
look like
moving
they're
around.
jerking around. Well, the reason for that is because the image from the person, or in this case the stick, comes to your eye only when the light is on. Then when they turn the light off, the people move into a new position, then the light comes back on and you see it. And it so
Okay.
happens that the television set is giving you 60 new pictures every second. So when you run the stick up and down in front of it, you're seeing a stick again and again and again based on the 60 cycle.
So it's cool that way. But yeah, we can continue on.
Okay. Another easy way to observe that the light from the sun is not parallel is to notice how the light from the sun does not light up the entire sky evenly. The sky is brightest immediately around the sun and then gets less bright as you get farther from the sun. We can see the same effect with candles. A candle does not light up the entire room evenly. The light is brightest immediately around the candle and becomes dimmer over distance. Also think of a candle's heat. When you are closer to the candle, it is hot. When you are farther away, you feel less of its heat, just like the sun. If a person were to throw a rock into a pond and watch the ripples move across the pond, it can be observed that the ripples are bigger near the point of the impact. And then as the ripples spread out, they get smaller and smaller. This is an important observation to remember because the light is a wave. When observing ripples, people generally don't describe ripples as parallel beams that move across the water. That very thought of it sounds incredibly silly. Yet so many people today describe light that way. This is a prime example of how our understanding of how light works greatly affects our understanding of astronomy, and, as in this case of Eratosthenes, it greatly affects our understanding of the shape of the Earth itself.
Thank you. Awesome. So, any thoughts on that?
So, if you're talking about the sun like a ripple, does that mean, so when you draw a sun, it's got like the lines going off? Those are lines?
You're always drawing them with lines coming off of the sun.
Would it be more of a line or would it be more of a ripple with like the curved lines around?
Well, right here you can see the dimming effect with the sun, which is more like a ripple. It's really bright, really close to the sun, and then as it gets farther away, it gets dimmer and dimmer. You don't always see it this strongly, but in these instances, I chose these ones specifically because they looked a lot like the candle.
Yeah, but like, do you get what I'm saying though? Like, when you draw a sun, usually people draw like lines coming out.
Yeah, people are always talking about rays of sunlight, right?
Is that right?
Rays of sunlight, and there's sunbeams.
Though?
We hear that.
Is that right though, or is that not? Because I know that other people draw it with like the lines curving around the sun, going like that.
Yeah.
I've drawn it both ways.
There's crepuscular sun rays, which is like if you see light shining through like dust particles or something like that, then it looks like a ray, right? That would be kind of like a sun ray.
Are they rays?
Not exactly. Right here we're talking about.
So it is more like ripples.
It's more like ripples, yes.
Oh, okay.
Yeah. So it kind of looks like a ray when you see sun shining through the trees, through dust or something like that, but in fact it's actually a ripple. And so it's kind of a misnomer. And so it's forever changed my view of sunbeams. Sunbeam, I'm like, wait a second, there are no sunbeams. It's not a beam, it's a wave. You gotta think about sun waves. It's kind of weird because it's not immediately noticeable unless like you're looking for it.
I have another question though. Like in your picture of the ripples in the water, you're saying that the ripples are bigger up close, and then when they go farther, then they become smaller. In the picture, like in the very center, those are tiny little like waves, and then it's bigger.
Kind of a big one. That's kind of typically how it goes. It starts off really deep, like deep waves.
Oh, deep waves. Okay.
Yeah, they're deep waves, and then as
they spread out more.
They spread out more and become more and more shallow until it's level.
Okay.
Until it just kind of dissipates. But that you're noticing stuff like that. So this dimming effect, there's a complex term for it called the inverse square law of light, which I'm not going to get to just yet. We're probably going to talk about that more later, probably in chapter 3 or something. So right in that. But yeah, it's a really big deal when it comes to a lot of different things.
Do I get to watch the video?
Oh yeah, we can go watch that video right now on Light is a wave. You've probably seen that one in school before.
Here's a question for you. If you shine a light on a coin that's hanging in midair, what do you think its shadow will look like? Do you think its shadow would have a bright spot of light right in the middle of it? Because it would. It might seem counterintuitive, and 19th century physicists thought so too when they tried this experiment. But that little spot in the middle of the coin's shadow helps prove one of the most important discoveries ever made in physics. Light is a wave. One of the most important reasons that light acts the way it does is known as Huygens' principle. Christian Huygens was a 17th century Dutch physicist who believed light acted as a wave. When a wave moves through a slit that's roughly the same width as its wavelength, it travels past the slit in a circular curve that spreads outward. When waves are reshaped by obstacles, that's called diffraction, and it's very different from what a stream of particles would do.
Diffraction is the phenomenon of bending of waves near the edges of obstacle or aperture. Water is filled in the rectangular glass bottom trough. A wooden scale is rhythmically dipped and taken out. This results in plane waves. Plane waves passing through aperture bends near the edges, resulting in circular waves.
Go ahead and read that.
Okay. How do we know light is a wave? In 1665, an Italian physicist, Francesco Maria Grimaldi, wrote a book called Physico Mathematis de Lumini Coloribus et... I can't read Italian.
Okay. Physico Matthias de Lumini Coloribus et Iridae. That's okay. Don't worry about it.
Wrote a book called blah, 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 blah. When he documented the behavior of light in his studies, he observed
where he documented
the behavior of light in his studies, he observed light bending around corners of objects like a wave instead of maintaining a straight line. He also referred to this bending of light as diffraction.
He's the guy who made the term diffraction really popular. So I got the definition of diffraction here, the physics definition, and then this is kind of cool how I've got his actual book.
Wait, that's his actual book?
Yeah, this is a link to his actual book in Italian. So,
if you know how to read Italian.
Yeah. Well, the main principle here is it's really important to be able to show where we're getting our information from, because you don't see this in traditional textbooks, right? Yeah. Oh, he said it, then they don't really link you to anything as to where he said it. At least they don't make it easy for you to go read it for yourself.
Yeah.
Sometimes they'll have like a link. Oh yeah, there's the name of this book, and you can look for it in your local library. That's your best you can do, right?
Or like sometimes in language arts, they always make us, what it's called? They make us like put parentheses and then the author's name and the book name and the book page.
Like anyone actually follows those paper trails to the sources. You kind of can try that with your local library, but often, like your local library is going to be able to have that book available for you. Yeah. And so that's what I really like about this book is it's easy to access. I've already done all the work for you, so now you can just go and quickly do that. And the cool thing about this book is Google Translate can turn it into English for you. So, yeah.
Or you can just use Duolingo and practice.
That too. Okay, next page.
In his book, one observation Grimaldi wrote about was the observation of light passing through two holes. In this image, we can see the width of the holes with non-parallel sunlight passing through them. The lines L and M represent a continuation of the shape of the holes and lines. N and O represent the max distance of a non-parallel straight line could pass through the tunnel. The dotted lines L and K show the light going beyond the limits of perfectly straight, non-parallel lines and show them diffracting around the corners of the tunnel. This is significant because in this one observation, he examined both how far off from parallel the sunlight was and how much of that was due to diffraction.
So that's an actual picture from his book. You can see the L&M right there, that's straight.
Okay.
And if the light from the sun was perfectly parallel, all the light would stay there within L&M. And then we have...
L&M wasn't perfectly parallel.
Oh, you're right. Well, it would be pretty close to that. Yeah, it'd be pretty close to that. And then you kind of see the light going wider than that. Go ahead.
Okay. Predating Grimaldi by far, the ancient Chinese wrote about a similar observation in the Mosai
writings.
Mosai writings around 500 BC. They discovered that when light passes through a tiny pinhole, it can project an image. Well, that's cool. People today often use this concept to make pinhole projectors so they can see the sun without looking directly at the sun during a solar eclipse. If the light from the sun was parallel, the light hitting the paper would be the size of the pinhole, and the pinhole projector wouldn't work.
So there's a link to how you can make your own pinhole projector. Just a little piece of tin foil on there, poke a hole in it into a box. And this doesn't just work on the sun, but you can look at other things outside to get these projected images.
Wait, how do you make the shape?
The shape?
Yeah.
What do you mean?
Is that a shape of a moon?
Okay, so this is sunlight coming through it, and you're pointing it right at the sun. And that way you can actually see what the sun looks like through the pinhole projector without directly burning your eyes out by looking right at the sun.
Cool. So it's like a big helmet?
This is one version, but yeah, this one can be used as a big helmet. Other times people just use cereal boxes and just make a little tiny opening that they can just look through, peek their eye through.
Cool.
Yeah, so there's different ways of making it, but the concept is still the important thing, that these things would not work if all the light from the sun was parallel. Okay. So that's that page. Any other thoughts on that?
Mm-hmm.
Last page.
Okay. The double slit experiment. Adding yet another puzzle piece to this puzzle comes the observation of Thomas Young. In his double slit experiment in 1801, Young discovered that when light shone through two slits, he didn't see two slits of light as one would expect if light was parallel, but rather he saw multiple slits of light. With this, he discovered that the waves of light were interacting with each other, similar to how one wave of water can interact with another wave of water.
Okay, so any thoughts on that? Any thoughts on that?
I mean, how does like the waves of light actually like interact with each other? Like,
well, it's because it's a wave, and so you kind of look down here, and how here he's got two different bobbers, and I've got a video here that this is connected to, where he's just taking two little balls and dipping them in the water right next to each other really fast, and because one wave is kind of affecting the other wave, it's leaving all these little lines in the waves.
Cool.
And so this exact same effect is happening with the light.
So that's how you get the rays of light? No? Maybe?
No, it's still waves. Okay, it's still waves, but when you look at the picture of the light source here with the multiple lines in it, it's these multiple lines that are kind of caused by the one wave canceling the other wave out. See how it's going wave, no wave, wave, no wave. No.
Cool.
That's kind of how it goes. So let's go ahead and watch that video real quick, and I think we'll close it up.
Okay.
I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wave fronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light. When the light from one slit met up peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light canceling itself out.
So, what did you think about the video?
I thought it was really interesting.
What do you think about the puzzle pieces here in this picture?
Like puzzle piecing things together?
Yeah, that's kind of a recurring theme here. And I feel like there's just like one piece that connects to another piece, which connects to another piece. We got this big, huge chain that helps us really see the big picture compared to NASA, and they're claiming, oh yeah, the light from the sun is parallel, right?
Yeah.
And so it just becomes very, very obvious who's got the bigger picture. And so with all these different puzzle pieces coming together like this, any other thoughts on all of this?
Well, I guess one thing I did notice, like in the wave ripples, like they, at first, like they were going a bit crazy and then they became like a constant pattern.
Mm-hmm.
I thought it was a little interesting how it didn't keep changing. Like it started to change and then it stayed at the one pattern with like the spaces in between the waves.
Mm-hmm.
Thought it was cool.
Yeah. I think if I were to add another page, because this is the last page, I'm going to add a page on vocab recap, which I haven't added yet. And then if I were to add another one, I'd probably talk about how waves can also be seen in clouds. You think about water waves, right? But you can also see waves in clouds.
I've seen those.
And so there's a big, huge thing on manipulating the weather through frequency and through changing the waves. You can use like the subsonic, it's the waves that you can't hear, but you can use sound waves, inaudible sound waves, to change the weather.
Is it bad for our hearing?
You can't hear them, so it's not going to affect your hearing, but it's still pretty weird that they're trying to change the weather through this, and I might do that. And I've got a whole bunch of other pictures here to go with that.
Oh, I don't really like that. It's like, it's just so man-made that it's a little sad.
Yeah.
I've been reading the book called The Giver, and they were talking about like weather manipulation and how like they completely controlled the weather, that they didn't have like any sunlight, so there was like no color. It was just black and white, and like, so there's like no color, no clouds, no sunlight. Like they didn't even know what sunlight is until, of course, the main character finally like found out by his power thing.
Yeah. Totally. I've seen this out in St. George, actually.
Like that exact thing, like it's
like
totally...
I've seen clouds doing this. I was like, that is so weird. Why are they doing that?
Like
some people are trying to dismiss it. Oh, it's totally natural. It just happens on its own.
That's not natural.
Yeah. But yeah, it's weird. But yeah, I might add that page, talk a little bit about that, and the HARP program, which is the government's weather modification program. And yeah, so
I feel like he looks evil in that picture.
yeah. So
He looks like a guy from Batman.
So next time we'll talk about the House of Cards. That's the name of chapter 3. And it's just a ton more big NASA claims that just gets totally demolished when you understand these other puzzle pieces that they're not playing with. You know what I mean? That totally fit together. Yeah, it's just really fun. Thanks for joining me. Until next week.
See ya.
This message has been brought to you by the Flat Earth Institute of Science. Powered by Miro. If I've said something that you disagree with, come reach out to me there. Our door is open.